All right, everybody, welcome to another OpenShift Commons briefing. This time we're changing the format a little bit, and we're going to do a live AMA, Ask Me Anything, with the OKD working group members, myself, Christian Glombek, Vadim Rutkowsky, and Michael McCune and Charro Gruver. I think I've said that wrong, but that's okay. I do that all the time. Are here to talk a little bit about what OKD is to set up the stage. And we have a couple of demos that we'll probably give, but we are streaming live on Twitch, on Facebook, and on YouTube. So we'll try and dump all the questions into this one chat and see if we can get a conversation about what is OKD and why you should try testing out and working with us to keep OKD4 out there in the universe. So I'm going to let Christian Glombek, one of the co-chairs for the working group, kick us off with a little talk about what is OKD.
All right. Hi, everybody. So this is a condensed presentation about what is OKD4. We'll have on the agenda what is OKD4 first of all, then what is Fedora CoreOS. Then we'll quickly introduce the OKD working group, and after that we'll start the Ask Me Anything session. So let's get this going. What is OKD4? OKD4 is our community distribution of OpenShift. So it's the origin community distribution of Kubernetes. The OpenShift code base running a top Fedora CoreOS. So usually in the OpenShift product, you'll have the same code base on the cluster, but then you'll have Red Hat Enterprise Linux CoreOS as the base operating system. We're replacing that in the community version with Fedora CoreOS. You can find all the info on OKD.io. This is a little bit of a visualization of OKD. So we have the application layer on the top. Below that is running Kubernetes in our OKD OpenShift flavor. So that is operator-driven Kubernetes on autopilot, essentially. You'll get automatic updates in the future, and you'll have the great thing that you actually manage the base operating system lifecycle together with the cluster lifecycle. So it's not different lifecycles anymore, but just one lifecycle for both the Linux host and the Kubernetes platform. And that runs on almost all the clouds. So really you can choose your favorite provider and run OKD on top. What is Fedora CoreOS then? Fedora CoreOS is an automatically updating Linux operating system. It's aimed at containerized workloads. It's based on our technologies RPM OS tree and Ignition. OS tree, you may know from other projects like Flatpak and a few other things as well. It's an image-based image-based composes that make an operating system, so it's semi-immutable. There's only a few parts you can actually change. So that's enhanced security, and it allows us to actually replace one OS tree commit with the other, updating the operating system. We use CoreOS assembler to build the images. You can actually run that yourself and build your own operating system images with that tool. And for Fedora CoreOS, we use the Fedora RPM packages from the official Fedora repositories. Next up is the OKD working group. So yeah, this is us, Diane, Vadim, me, and Charro, and a lot of other people that chime in. So we're present on Slack, on the OpenShift dev channel, on the Kubernetes Slack, and we also have the OpenShift Commons Slack, where we're really in all the channels. The general channel is probably the best entry point there. Then we also have a Google group, which we also use as our email list. We have bi-weekly video conference meetings. You can find the dates on the the OKD calendar, on the Fedora project calendar. And you can find all the info as well in our repositories in the OpenShift organization. The OKD repository is the technical one, and the community repository is more of the organization, contains all the organizational things for the working group meetings and other community related things. And with that, that was just a really quick walkthrough. With that, I'd like to open it up for the AMA. I'm not sure if anybody else wants to chime in before we open it up.
Yeah, so I'm gonna, that's the slide we wanted to really highlight here. And part of the reason we're doing the AMA is that OKD4 is in preview now. I think, Vadim, correct me if I'm wrong, I think we're at beta 5 at the moment. And so just to emphasize, OKD is the open source side of OpenShift. And you can think of it, I think we've described it as the sibling as opposed to an upstream release process. And maybe, Christian, you want to talk about the sibling mentality of OKD just a tiny bit about
sure.
why we're calling it a sibling as opposed to a upstream.
I'll quickly go back to the slide for this. It's really this one. So we use the same code base as the OpenShift product. We just run it on top of a different operating system, which is why it's not, well, the operating system, Fedora CoreOS, is upstream to the RHEL CoreOS. The actual cluster code, the Kubernetes and operator code we use is the same. So that's why it is, it's difficult to describe, but I think sibling distribution probably fits best here. So it's the same cluster code, but the operating system is a different one.
Yeah, and like siblings, we're always wrestling for resources and attention. So, and part of the reason we're doing the AMA is really to engage with the community. There's a lot of folks external to Red Hat who have been partaking in the OKD working group. Some of them are here with us today. And we also are trying to figure out ways to enable the people to test on all of the different platforms. And one of the folks from Charro Gruver is here, and he has been doing most of the work making single cluster installs workable for OKD4. And so, Charro, you want to tell us a little bit about what you're doing and how you're doing it and how you're making that happen? I know in the context too of we're still waiting for, I believe, and please correct me if I'm wrong, code-ready containers for OKD4. So part of the reason we started down the single cluster was there wasn't a CRC for OKD4 yet, which I think is in the works or something. So maybe talk a little bit about what's going on, so how people can actually test this stuff on their own machines or home labs.
Yeah, absolutely. So the goal that I had for the work that I've been doing is to enable someone to achieve a local operations or development environment. And really, in the roles that I play, I sit on the fence between both operations and development, and I'm a huge fan of bringing those communities together. I think developers write better code if they understand the infrastructure that is executing their code. And I think operations engineers build better systems when they have an appreciation for the applications, right? But it's difficult for you to gain an appreciation for those things if you can't get your hands on the gear that makes them work. So, a production-ready OpenShift cluster requires a fair amount of compute and memory resources to stand it up and get it running. And no matter where you are, that translates into dollars. So the work that I've been doing is to get something that is approachable for someone that may have a piece of gear laying around. If you can run a RPM-based Linux operating system with libvirt on it then most likely you can get a single node cluster up and running. Vadim recently got a pull request approved and into the beta 5 that has really taken this a further step, because previously you had to do some gymnastics to get the etcd not to be upset during the bootstrap process, because there was only one of it. So some recent changes that were made allow you to run and install with just a single master and no workers designated, and get a cluster up and running that way. If you go to my GitHub page, which we can probably drop a link to it in the chat or something later, I've got a prepped tutorial that will take you through the build of a single node cluster on a CentOS bare metal device. The only thing you need is CentOS 7.6 I'm currently using. I'm going to test 8 to see that it works as well. And at least 20 gigabytes of RAM, 32 gigabytes of RAM is best, but most inexpensive little tabletop server machines are fairly approachable these days. It uses DNS load balancing, very poor man's load balancing, so you don't have to stand up an HA proxy instance or anything like that. What I like about the approach that I've taken with this single node cluster over something like code-ready containers, which will be easier for somebody to stand up, but less transparent. If you go through the effort of standing up this single node cluster, you're going to learn a ton about OpenShift, OKD specifically, and how it installs, right? Seeing the bootstrap process, watching the magic of the bootstrap node, creating the master node, seeing how the ignition files actually work and the operating system standing itself up. You'll see the OS tree magic happening as the Fedora Core OS replaces itself from the initial boot to the final version that you're actually going to be running. So while ultimately we're going to have code-ready containers and something that you can basically download, double-click, and run, I'm still a huge advocate for you opening the hood and seeing a little bit of what's running underneath. So if you take a look at this tutorial, it will get you all the way through to a fully functional, fully running OpenShift cluster that is one master worker combination, all in one virtual machine.
Cool. And if you want to pop that URL into the chat, we'll share that out and people can give us your feedback on that. That doesn't mean we don't want that code ready container for OKD4. It just, I think, what is the status of that, Vadim, at the moment?
I'm not entirely sure. We have a prototype, but CRC folks are deciding which way do they want to go. Do they want to stick to OKD, or do they want this as an experiment? It's their call, honestly. Okay. If they would prefer to stick to OCP as an official name for CRC, we could come up with our own OKD4 based code-ready containerish thingy. So that's not really a problem.
Okay. Yeah, Vadim was even kicking around a pretty interesting idea of bootstrapping with a container rather than an actual instance of a virtualized operating system, which would make the work that we've been doing just that much more portable and require a little bit less resource. Because currently, even when you build CRC, you still have to go through the standard installation process. So you do have to have a bootstrap node and at least one master node that are up and running. The bootstrap process has to complete itself, and then you can destroy that extra machine. The containerized route that Vadim is thinking about would make that a little bit less heavy lifting, and would enable us to create a CRC download that people could pull down and effectively double-click install onto their local workstation.
All right.
What stops us from being able to do that with even with the VM-based payload. I mean, like, it's not like there aren't APIs to orchestrate that.
No, that's absolutely right. And that's currently, if you look at the Code Ready Containers is built from two projects. There's the sub project is SNC, single node cluster, which you can find on GitHub under /CodeReady. And that effectively builds a libvirt infrastructure provisioned or installer provisioned infrastructure instance of a single node cluster. And then the CRC takes that virtual machine image once the install is complete and bundles it up as something that then you can distribute. One of the challenges with it, though, is that once you're running it, you can only access it from your local machine unless you're willing to do some network gymnastics and stand up an HA proxy instance or something. Whereas the single node cluster that we've been playing around with is actually sitting on your network as a machine on your network, and therefore is accessible off that machine. So there's definitely more work for us to do on it to take one of these two routes and create something that's easily distributable. But that's kind of the state of where we're at today.
So I'm going to pause because we have a couple of questions. Waleed has asked, what is the status of OKD when it comes to VMware, preferably VMware Cloud Foundation, and that is not just vSphere storage using vSAN network using NSX-T. Anyone got an update on where we're going with vSphere and VMware? Vadim or Christian?
I can semi-answer that. So we talked about sibling distributions. In practice, that means that we are following OCP. That means we are using all the containers built exactly as they are in OCP for the majority part of the operators, for their payloads and things, and then just ensure that it runs on Fedora CoreOS. So as soon as OCP nightlies would be able to support any random platform, be it vSphere API in case of 4.5, vDirector and all of that stuff, the OKD would get those for free. However, we cannot deviate too much from OCP in this manner. We can experiment and file pull requests upstream because that would touch quite a lot of operators. And we don't want to carry those patches in OKD. We, however, definitely support experiments of all kinds of new platforms and things, and we will be able to help with those. But we cannot put this as an item for the next beta, for instance, or for the release, because that we have to follow OCP in this manner. So you would probably file an enhancement for the OCP saying support of additional vSphere platforms, VMware platforms, and so on. Have it approved, and folks from various operators would be able to work on that. That's basically the process how to get that in the OKD.
All right. So, and Chris was just go ahead.
Yeah, maybe to add to that. Yeah, we're following the OCP development here. So unless that's on the OpenShift roadmap, on the product roadmap, we won't have it anytime soon. So I think the way would be to create an enhancement proposal, get that merged, and then it'll be put on the OpenShift roadmap, the roadmap for both the product and the community project is. So I'm not aware that right now any additional VMware platforms are on the roadmap.
Yeah,
just for that specifically.
Yeah, I haven't seen it, and I'm digging up the roadmap here in the background, so I don't see that yet.
I guess I could add a little more upstream context if we want.
Okay.
So I'm working on the cloud team, which is interfacing with the upstream cluster API project, which is where we get a lot of our actuator code, for these various controllers from. And although there's quite a well-developed Vsphere implementation upstream, which is what we use for Machine API as well, I have not seen the upstream with like an alpha version or anything of the VMware Cloud Foundation yet. I actually just heard about that recently myself. So I haven't seen if there's been an experimental version or alpha coming there yet. But presumably once it arrives in the upstream, as described by Vadim and Christian and Diane, if this comes into the product, then we would bring it from upstream back into OCP and then onto OKD from there.
So there's a question came in from YouTube, semi-related, and I think maybe Charro tried to answer it in the chat, but is it possible to install OKD4 with static IP, Vsphere UPI? Apparently they tried the same procedure as in OpenShift RH CoreOS and it didn't work for them.
There was a period of time where Fedora CoreOS wasn't respecting fixed IP addresses that might have been configured through the KARGs directives when you boot, but that has been fixed, and I'm pretty sure it's all the way up into the stable channel now. That with kernel args now booting a Fedora CoreOS node, it will respect the IP directives even for multiple NICs, and it will persist the host name that you give the machine. So yeah, I've been running my lab with fixed IP addresses for a while now, even using 2 NICs, because I use the second NIC for a storage area network that I've got with some iSCSI SAN devices.
If I remember correctly, this was fixed in late February, because I vaguely remember these changes actually landing in Fedora CoreOS and an ignition update to go with it to make it so that they weren't just accidentally being scrubbed when they were being passed on to the kernel. So as far as I'm aware, that should actually be an okay now.
Mm-hmm.
Yeah, I think that should work. There is one catch at the moment, though. In Fedora CoreOS, there is an issue where the naming scheme is not the same as in RHEL CoreOS. So we right now default to the legacy naming scheme. So the interface name would be ETH0 on Fedora CoreOS and ENS192 on RCOS on RHEL CoreOS. So that might be an issue that that you caught here if you try to name your interface ENS192.
So one more.
That should be fixed sometime soon, though.
Okay, so quick question, which might be a little generic, but at least if we can get a link somewhere to someone from Facebook is asking, can you explain Ingress? Might be I think.
That's inbound routing. That's just, so ingress is just when traffic is hitting the cluster, either to go to an application or go to the console or go to some other endpoint. Ingress is handling that request coming in and passing it through to the correct destination. So that can be a route through HA proxy or Nginx or whatever. But ingress is just literally referring to the Kubernetes concept of just routing traffic inward. Egress is routing traffic outward. In OpenShift, we conceptualize this as routes, which I arguably think is actually a better term for this because it's a lot more. It's a lot easier to grok what that means. But that's what it is.
Thank you. Perfect. There's no too basic of a question anywhere. And thank you for that. That was great. From YouTube, there's another question. Is there any possibility to roll Kubernetes for IoT devices at all? I'm assuming with OKD. He means updating end devices, operating systems over the air since we've been talking about bootstrapping to small hardware.
So yes, most of the blocker here is we don't have a way to orchestrate beyond like a single network system. Like when you're talking about IoT rollouts, you're talking about wide area network orchestration. And I can promise you right now, nobody has been thinking about that right now. wide area network orchestration is extremely difficult to get right, and that's the real problem with it. Like getting the cluster nodes to fit small enough to work on what we would class as IoT hardware. That's actually the easy part. The wide area network orchestration is the killer problem right now. And Kubernetes upstream has no good support for this because it makes the assumption that the networking below its layer is flat. But at a wide area network layer, you're talking about multiple levels of hierarchies, NAT traversals, all kinds of fun stuff that nobody ever wants to think about. And those are all things that are not currently handled today by any Kubernetes distribution, as far as I'm aware. But if you are interested in doing something like this, come and talk to us about this stuff, because, like, goodness knows, it would be very cool if we could do that.
That would be totally cool. And yeah, join the OKD working group. I think there are a few people exploring Kubernetes on the edge in IoT. So, and it's something that hasn't come up in a topic yet in the OKD working group. The other thing, I wanted to pause for a second and give a shout out to the Fedora CoreOS folks and the people in the Fedora community, because they've been really good collaborating with us, getting, not quite in sync, because we don't expect them to be totally in sync with our release cycle, because it's a little, it is what it is. But they have been incredibly responsive and been participants in a lot of cross-community collaboration here. So yeah, a big shout out to Fedora and the whole Fedora community for their help with this.
They're always very responsive when we open issues, and they're very helpful.
Yeah, we can learn a lot for them, and we have been. So that's been a great collaboration. So the other thing people have asked a lot about, and I've asked Michael McCune here today to come to answer, because we keep getting questions about auto-scaling quite a bit. And I'm wondering, Michael, if you could take a minute and talk about some of the conversations we've been having around auto-scaling OKD.
Yeah, definitely. So in last week's working group meeting, there were some great questions about, does cluster auto-scaling work for Vsphere, and what are kind of the mechanisms behind that? And so we started to talk about, kind of what is cluster auto-scaling on Kubernetes and how does it work? And in OpenShift and in the upstream Kubernetes, I should say in the Kubernetes Autoscaler, there are several different providers that it needs to talk to, in order to actually do the action. So when you deploy Kubernetes and you put the Autoscaler out there, normally you're associating some sort of provider with it to do the work for you, whether that's AWS or Google or whatever. And there's a project called Cluster API, which OpenShift uses as Machine API. And this is an abstraction that allows us to look at providers through custom resources like machines, machine sets, and machine deployments. And much in the same way that we look at applications through pods and deployments and replication controllers, this allows us to start treating Kubernetes clusters in the same way, with a declarative language about these things. And so recently, we've integrated the Cluster API into the Kubernetes Autoscaler, and this is really the backbone of how autoscaling is done in OpenShift. And so any provider that is provided by the Machine API in OpenShift can interact directly with the Cluster Autoscaler. So whether you have Vsphere or whether you have AWS or whatever your implementation is behind the Machine API, the Cluster Autoscaler just talks directly to that Machine API by creating new machines, by increasing machine set replicas, and in this way, the Autoscaler does work for you within your cluster. And so that was kind of a high-level discussion. There was some requests to see how this works and whatnot, because there are a few resources associated with it. So yeah, so whenever we're ready, I'll kind of dive into that. But that's a high-level overview of how the Autoscaler works.
Had myself on mute. Yeah, if you could dive into it a little bit deeper, that would be great. We have a little time. We have a lull in the questions.
Okay.
So go.
I guess should I just share my screen and start kind of diving into this?
Absolutely.
Go for it.
Yeah.
Sounds good.
We're all fascinated.
So let's hope this works. We'll first step is, can I share my screen?
Years.
Okay. So hopefully everyone is seeing my terminal now.
Yep.
And you can just see, so I'm dealing with a server that's at the 4.4 OKD. I think I downloaded this a couple days ago and set it up. And at this point, I'm in a project called OpenShift Machine API. And this is the project that you want to be in if you want to kind of assess how these things interact on your cluster. So if I do get machine sets here, we'll see the various machine sets that have been deployed for us. Now, you may notice that there are 3 machine sets here. Each one of them has 1 machine in it. But if I do a get machines, we can see that there's actually 6 machines that make up this cluster, but only 3 of them are represented in the machine sets. Now, some of this is because we do not put masters into a machine set currently. Masters are handled a little separately. And so they don't appear in those machine sets, but these machine sets are where our workers are occurring. And so what I'm going to walk through now, and I'll show these manifests that I'm going to be applying. And what I'll do is, as I'm applying the autoscaler and we're applying a workload and we'll see it scale out, that'll take a little time. So I'll show a quick preview of some of these manifests while I'm applying them. And then as we're waiting for the cluster to scale out, I'll go back and kind of look in depth at these different things. So to begin with, if I just get the pods in this project, you can see, we've got a cluster autoscale operator, we've got the machine API controllers, and this is what's actually talking to the cloud, and we've got the machine API operator. Now, the machine API operator is what's looking for the machine sets and the machines and whatnot. This cluster autoscaler operator is looking for resources like a cluster autoscaler and a machine autoscaler. And you can find links to examples for all these in the OKD documentation. It's under the managing machine section. So the first thing I'm going to do, though, is create an autoscaler, because we don't actually have the autoscaler running at this point. It doesn't start by default. You have to engage it. So first thing I'll do is I'm going to run this manifest to create a cluster autoscaler. And I'll come back and describe what all this does after things are going. I apologize for the keyboard. It is what it is. So we make a cluster autoscaler. I look at the pods, and you can see that it's already starting to create the actual autoscaler for me. So that won't take too long. Now, the next thing I need to do, though, to actually make this work is I need to create a machine autoscaler. And this is a resource that will tell the cluster autoscaler that it should look at a machine set and that it should scale that machine set. So I'm going to pick one of my machine sets here, the one called 2A, and I'm going to use that as my scaling. And you can see I'm giving it some endpoints here, min replicas and max replicas, and this will kind of control how it can scale. So now when I go to get the machine sets, nothing really has changed at this point. Everything looks pretty much the same. And part of this is because the cluster autoscaler will not scale up until it sees pods that are in a pending state. So it will attempt to scale up whenever it can, but only if it sees pods that are waiting to get assigned somewhere. And likewise, it will scale down when it sees nodes that are underutilized. So the next thing we need to do is create a workload to actually force this to scale up. And so I've got a small manifest here that just creates a deployment and does, not too much. It just creates a container and sits and sleeps there and puts out an echo for us. Now what I'll do is I'm going to create this and I'll put it into another project. And at this point, if I just look at the pods in that project, you can see we've only got one, it's running, so nothing is really happening at this point. But what I'd like to do now is scale this out to a bunch of nodes or a bunch of replicas so that we can, hopefully force the cluster to scale out. Now, if I look at the pods again, at this point we see there are a bunch of pods in the pending state. So ideally, some of these will get resolved immediately, but many of them are still in the pending state. So if we look at the machine sets at this point, what I should see, if I can type it correctly, is that the one that we have specified to have more is growing out now. So it's desired to have 4. It currently should have 4, but none of them are ready yet. And this is where you might start looking at the machines. So we can see there are 3 machines. 2 of them are still in the provisioning state. 1 of them has been provisioned. Now the machine is an abstraction that sits above the actual low layer here. So if I look 1 step below, I look at the nodes. What we see here is 6 nodes. Now this may look a little weird to begin with, but the new nodes won't appear here until they're actually ready to be running. So we won't see them until they're actually ready to be addressed by the machine, by the cluster, I should say. So I promised I'd go a little deeper into some of these manifests. So what I'm going to do is I'm going to get the machine sets and we'll just watch this, because eventually what will happen is we'll see more machine sets come up. But this can take 2, 3, 4 minutes depending on the cluster, depending on the cloud provider you're using, and just what's happening at that moment. So I'm going to let that kind of go there, and we'll leave that running up at the top. And what I'd like to do now is look a little closer at these manifests that we created. So the first one that I ran was the cluster autoscaler. Now you can see, I've chosen this kind, cluster autoscaler. This is the resource that you want to create to actually instantiate a cluster autoscaler. And OpenShift only runs 1 cluster autoscaler at a time. You can only have 1 of these running, and it must be named default. And this is the way that the system kind of looks for these things. Now, in the spec, though, you can see I've got a bunch of options here. Balance similar node groups, ignore daemon set utilization. These are actually options that I'm passing into the autoscaler that starts for my cluster. So if there are reasonable defaults that are set, and if you look in the documentation about the example for this, I think you'll see something that's very reasonable in terms of some of these things about ignoring the daemon sets and the delay after add. Some of these I've changed so that I could give a different demonstration here, so that it's looking at a much smaller time, for when it should do things. Now, another thing to keep in mind here is these resource limits. This is going to limit what the autoscaler will do across the entire cluster, not just what it's watching. So this max nodes total 24. Those aren't just the nodes that the autoscaler is watching. That's the nodes for your entire cluster. So you can, if you have a hard upper limit, you say, I never want to go over 24 nodes across everything, whether the autoscaler is watching it or not. This is how you would kind of prune those things in. And likewise, I can set limitations on the number of cores and the amount of memory that can be seen across the cluster. This is, again, more ways for you to tailor the autoscaler to your specific needs. And then I'll go down a little bit. These scale down options here, scale down is, I think it's enabled. It may be enabled by default. I'm not sure, but you have to turn it on. And then you can change these delays for how long the machine, the autoscaler should watch before it decides to, mark a node for deletion or what have you. So that's kind of the first thing that I did, was I created the cluster autoscaler, and that instantiated it. And you can see at this point, I haven't mentioned anything about the cloud provider. All that information is contained in the machine API. And so I haven't really had to pull out any sort of credentials or tell it where to do this. That's all being handled by a different component at this point. So I'll look now at the machine autoscaler, which is the resource that I created to associate my machine set with autoscaling activity. And we already looked at this one a little bit. It's much more simple. But basically, I want to create a machine autoscaler, which means I want to tell the autoscaler to look for some nodes and to manage those nodes. And as normal, I can give it a name. I'm sure some of you have noticed now some of our new machines have started to come online. And then really the main information for the machine autoscaler here is I want to tell it the minimum number of replicas and the maximum number. And then the other key piece of information, tell it what machine set that it should scale. Now, in 4.5, there will be support for scaling down to 0, but in 4.4, the minimum I can go is 1. So I've kind of left that in place here. And what happens with this is that when you create one of these machine autoscalers, what you can see happen. Now, I'm going to take a pause here for a second, because what I'd like to do is, now that we've gone to max size here, I'll take another quick look. We'll get the nodes just so we can see. We've actually added all these extra nodes as they've become ready now. And if we get our machines, we can see everything is now running, and it all looks pretty good. So what I'm going to do at this point, and we'll get the pods, we'll just look at the pods one more time and scale. Some of them might still be pending because, I increased the size of this way beyond the maximum of our cluster. So we're kind of at max size now, and it's not going to go anywhere. But what I'm going to do is delete that. You should see all our pods are gone. And now when I'm going to watch the machine sets again. And what we should see is, within about a minute or two, hopefully we'll see it start to scale down. It was a little slow scaling down the other day, so we'll see how this goes. But what's going to happen is, as it deletes pods, and as those pods get drained from the nodes that they were running on, the autoscaler will start to look for nodes that have, no utilization on them. As it recognizes that, it will then start to delete them. And as we can see, it's starting to delete them already. So it's starting to shrink the cluster to back down. Now, just to go back into the deep dive a little bit here, I'm looking at the machine autoscaler, and this machine autoscaler object is actually also being watched by the cluster autoscaler operator. And what's happening here is, under the covers, if I look at the machine set, so if I describe this machine set, I'm using a different terminal, so I don't have the credentials there. So if I come back to the right terminal, look at this, and actually I'll just go away at the bottom here. What we should see is the labeling that tells the machine autoscaler to look at this, but I'm not seeing it, so maybe, this is where things get exciting. Okay, so I've got a machine autoscaler. I get the machine sets. And I guess at this point, the demo is pretty much going. Diane, were there any questions or anything that have come up throughout this?
Oh, yeah. There are a couple of questions.
Okay.
I'll ask the first one from YouTube, and you may have covered it, but can you please explain if anything changed in evenly distributing pods across the cluster? Autoscaler feature is perfect for user-based workloads, especially when in dev test at prod environments. So anything changed in evenly distributing pods across the cluster?
So like, as I understand the question, so the autoscaler is not doing anything about scheduling pod workloads. That is still, the Kubernetes scheduler does that. What the autoscaler can do, and I don't think that we set this up, but I will look quickly here. Yeah, so balance similar node groups. What the autoscaler can do is that if we had set multiple machine sets, so if I had two machine sets that both could grow, I could have the autoscaler equally add nodes to those groups, to those machine sets. So it would try to add one to machine set A, one to machine set B, and back and forth. But it actually doesn't do anything for the pod scheduling. That's still handled by Kubernetes.
All right, well, maybe that answered his question. We'll find out in a minute. And Peter's asking question, how does the autoscaler do reconciliation of resources, i.e. if two nodes have 25% utilizations, could it make it one with 50%?
Oh, reconsolidation.
Oh,
yeah, no. Yeah, so the autoscaler will not reconsolidate your pod. That would again be a function of the Kubernetes scheduler. So the autoscaler is only looking at nodes and it's looking at the pending pods in the cluster. So it doesn't actually, it looks at nodes to see how much load they have on them. And if their load drops below a certain threshold, then the autoscaler will attempt to scale down those nodes. And it looks at pods in the cluster to see if any are unpending. And if there are any, or if there are any pending, if there are any pods that are pending and the autoscaler has the opportunity to scale up nodes, then it will do that. So that's, I hope that answers the question there.
Okay, and there's one more from YouTube. Does it support with direct LUN disks as pass through at the time of downscale and upscale with autoscaling?
Well, I mean, I think,
iSCSI.
yeah, that should all be handled at the machine layer. So it will mint whatever templates you've put in place for the machines and nodes. It's not actually, it's going to do whatever you tell it to do. So if you've created machine sets that have machines that have some sort of special storage or GPU or hardware, it will just continue to do what you've told it to do. It will not try to do anything beyond that, basically. I don't know, Neal, did you have something else here?
Yeah, so so with that, does the autoscaler gracefully handle when there is no more resource to give, when it needs to have more and it can't get it? Like, so if your machine set templates include requesting a resource that there's just no more of, so like everything else is there, but like you don't have another GPU to attach, or you don't have another MDev, or you don't have another iSCSI LUN, what happens in that scenario? Because it doesn't seem to be very well described what it does in that case.
Yeah, that's a great question, and especially in this case where we're dealing with, like, you know, it'd be one thing if you were just dealing with one provider, right? But because the autoscaler is actually talking to the machine API, you're not talking directly to the provider. So what would happen is, if the autoscaler, let's say the autoscaler still has room in its machine set, so it can scale up. But when you go to request from the cloud fails to create the machine or the node because the cloud is denying you the request based on resource limits or availability or whatever. So what you'll see is an error come back through to the autoscaler, basically that the machine API cannot allocate those resources. Now the alerts that you'll get from that, I think at this point probably are not as verbose as I would like to see them. We could always do more to make this easier to interpret, because I've run into this issue before where, like, it just didn't have the resources. But the autoscaler will handle it pretty gracefully. In the logs for the autoscaler, you know, you will see that it has attempted to scale up and that there's been a failure from the provider side, and it will just it won't, you know, upset the autoscaler, but it will continue to try and do those scaling operations as long as it sees the load there. It will just keep failing from the cloud provider side, most likely.
Okay, so we will eventually get locked out because of we're DOSing the API for requests, because
hopefully it won't happen with that kind of frequency. I think it checks like every 3 seconds or something like that. But
okay,
but yeah, like eventually, yeah, you're gonna hit. You're just gonna keep bugging your cloud provider, basically.
Yeah. So it doesn't have it doesn't have a way to say after so many tries, just stop and report I can't autoscale anymore.
That's a really good question. I don't remember if there's a back off in there that happens after a certain amount of time. It might be like, after 10 minutes of trying, it will stop or whatever.
Okay.
That's a great question, though. I'd have to look into that a little deeper.
Because I know that there are certain circumstances where I see if you have a quota imposed on you from your tenant supervisor, which also includes a rate limit, and that rate limit is so many requests within a time period, like if you've run out, like you could easily get yourself locked out of the API by being whacked too hard by the autoscaler. So if there is no backoff facility, there probably should be one.
Yeah. On that note, there is one more question from YouTube, and then we can run over the hour just so people know if people have time, but we're going to try and wrap up in the next 10 minutes or so. Someone on YouTube is asking, in case of auto-scaling databases, for example, MongoDB, how could be the election of primary and secondary replicas could be handled?
So I'm going to punt a little bit on this one because I think that's actually getting into the vertical pod autoscaler, which is different than the cluster autoscaler. So that would be about pod scaling. This is what I'm talking about is specifically just about cluster scaling. So that would be handled by whatever pod scaling methodology you're using.
Yeah. So
And note with something like MongoDB or any other database, this is more of a function of your deployment mechanism, whether it can do that particular election process for a cluster of databases. Like, for example, a MongoDB operator or a Helm chart or whatever, like that. The Kubernetes pod scheduler has no concept of understanding this kind of election or whatever. Like, this is usually a facility that you build on some kind of add-on functionality, like an operator, an Ansible playbook thingy, a Helm chart, or whatever. So no layer at the OpenShift level or the OKD level is going to understand what you're talking about. That happens at a higher level.
Yeah, exactly. I think I've seen people even mention using like stateful sets and stuff to kind of.
Right. Yeah. There's a whole bunch of different ways you can do it. It's just you've got to come up with whatever makes sense, and you won't forget how it works later. Like, that's the important part. Don't forget how it works.
yeah.
Well, yeah, and this is kind of the difficulty with building auto scaling stuff into, something like a database or whatever. Yeah, like once you scale it out, you might need to have this leader election and this other mechanics that need to happen. And, yeah, that's just so far beyond what Kubernetes is actually doing. You're now totally in, this is why people run Zookeeper and things like that.
So it sounds like this is a topic for another day, a deep dive on that. And I can totally see that happening sometime in the not too distant future. I want to circle back to OKD and the beta 5 release, because we get a lot of questions around release dependencies and the fact that it's beta 5. And I keep telling everybody beta 5, very, very stable. Go ahead, use it, test it, tell us all about it. But I wonder if we can get Vadim maybe and Christian to chime in here about what it's going to take to get to a GA release and what I would call true stability, or at least stability in the minds of people who might want to use it in production in enterprises or elsewhere.
Sure, I can explain a bit more what does beta mean in the context of OKD. So at this point, OKD is an image of Fedora CoreOS, an installer from OCP with a few additional patches, an operator called machine config operator with additional patches for Ignition 3, and the rest is exactly what you have in OCP. So we call it beta, and our goal for release is to drop those patches, keep Fedora CoreOS, so that any issue you filed for OKD will automatically be valid for the official installer team or any other operator team, and they would be handling. At this point, installer and machine config operator issues for OKD are handled by OKD team, but once we get rid of that, once all of our patches land upstream, we will call this GA because that would match the features for OCP, and it would be handled by OCP team, and there won't be a difference in this case. So on the road to that, we're planning to rebase an OCP 4.5 code in beta 6. We would bring in Fedora 32 based CoreOS. That would fix a few patches related to OpenStack and a few other improvements. And once we're done with that, we will fix a few things on the infra, get our patches merged upstream, and we can call this a GA if we won't have any blocking issues. We've created 2 milestones where we track issues on an OKD project. Once the progress bar reaches 100%, we would prepare documentation and things and get the official release. We also need an enhancement to the OpenShift project about the OKD, where we describe all the details, how OKD works, how it's different from OCP. When all the engineering of OpenShift accepts that, that means they would have to fix bugs related to OKD. So these are the main points on the way. We usually don't give any dates because on the OKD side, we are flexible to declare release anytime. We just want to fix the blocking issues. That's pretty much it. Yeah. Maybe Christian has something to add.
I think you put it really well. Maybe one thing, we're getting close to it. I don't want to set a date, but it's not long.
Yeah.
It won't be long. And so development, the masters are open again for development. So reviewing or reviews on our patches we need for OKD has begun, and we expect them to merge soon. And then when 4.5 OpenShift OCP comes out, we will rebase one last time on top of that, and we'll probably have a release candidate release first, and then we'll go GA, but it shouldn't be too long now.
Okay, so there's one question from YouTube, but I have one more thing that I'd like you to tease out a little bit too, is Fedora CoreOS images available on different cloud hosting providers like Google or Amazon or that. The last I heard, they were available for doing installs of OKD everywhere except Azure, or are they on Azure now?
Excluding Azure. Azure is still busted.
Azure needs a workaround. Joseph has created a pretty simple workaround for that. But once they are, yeah, we won't need it anymore, and that would be a bit faster. But we have a workaround how to install OKD on Azure, yeah.
All right, and there's one last question coming in and the workaround, I think we have a link to it that I'll post as well. So I'll post that or if someone has the URL to the workaround, put it in the chat and I'll post it around. The one more question coming in from, okay, well, there's two. Okay, they're coming in. If you can hang with me for a little bit longer, that's fine. Compute nodes are good fit to storage. I think this is grammar is a wonderful thing. Compute nodes are a good fit compared to storage nodes for autoscaling, or can I apply Autoscaler for storage, parentheses, Steph, HDFS, Ignite, etc. nodes also? There's a couple of questions coming in that way, and then there's another one at kind of mixing them up a little bit. The Kube service catalog pods are in quotes, crash loop back off state when OKD is installed in an environment where the internet is disabled. How can I bring these pods into running state? I think that second question that I just asked is kind of important.
Second question is also very hard to answer because
I can answer the easy one real quickly.
Okay, answer the easy one, autoscaling.
So the easy answer about like compute versus storage and autoscaling, there are a number of wonderful features associated with the machine sets in terms of being able to use selectors through annotations, labels, and taints. And you can actually tailor those so that when they deploy machines and nodes, those machines and nodes will take on those same labels. So if you have a situation where you just have a compute set of machines and you want that to autoscale, then you would create a machine set that's just linked to those hardware that you want to be able to autoscale. And you could, first of all, you would use selectors in that machine set to make sure that all your workloads were going to that cluster. So when I create a deployment or replication controller, I could put selector labels on the pods that are created such that they only go to that machine set, and then that machine set maybe has, high performance CPUs or has GPUs or some sort of special storage or whatever it needs to be. And in that way, you could segregate your workloads and control the auto scaling differently with each one of them. But it would mainly be through labels and those types. That's the easy question.
Okay, the hard question: crash loop backoff state. Is that a question we should punt and answer in a forum somewhere or something?
We need a bug for that.
Yeah,
And we need a tons of information to see what's actually happening inside there. We have a tool called mustgather, which fetches it for you so that we won't have to comment every time, give me that log and that log and that one. Once we have a bug, if it's supported scenario in OCP, it's definitely supported in OKD. And we could track it, and if it's important enough, we might log betas on that, because that sounds pretty bad. We definitely support disconnected installs.
Yeah.
And if it's reproducible, then we need to know the sooner the better.
So if you're still listening there, Nishant, go to the repo and log an issue, and we'll put the URL up for that in a second. Here's an easy question. You're all going to want to answer this. Can I run OKD 4.4 on Proxmox?
Yes, but by hand.
There you go.
Well,
do the bare metal
not
install.
Necessarily. Yeah, not necessarily. We encourage people to post their guides, how they run OKD in various scenarios. And we heard Proxmox quite a few times. And if you manage to make it work, we would definitely accept a guide how to do that. Use OpenShift OKD repo as an inspiration on how to arrange things together. That sounds like a very common case. So we definitely should have a guide for that.
I'm going to throw up the links to where you can find us online too, and where you can add some conversations and log issues. And really, if you can spend some time with us, join the Google group, that forum. It is a great place to reach out and post questions as well. And also in the Kubernetes Slack, I think that's really where you'll find most of us during the day. The Proxmox, I would love to see that stuff documented a little bit better. Not nudge, nudge, wink, wink. Somebody could write that up. That would be great. I'm looking to see if there's another question here. There's a bit of a question. I think I might have missed this. You may have answered this, Michael. Please help me correcting. Let's say if we have 30 nodes, 20 nodes started, and 1 minute on Autoscaler, remaining 10 can assign for Autoscaler to upscale and downscale. That's an awkward question, but did that make sense to you the way I read it out?
So let me see if I understand this. So let's say you have a cluster that contains 20 nodes that are kind of set aside for workers. You want to be able to scale down to a minimum of 1, and you want to create these other. You want to have 10 more nodes that could be, usable only for auto scaling. There's a number of different ways you could handle this. You could create a machine set that's just linked to those 10 other machines, and that would, or a potential 10 other machines. Like, if you already have the machines, then there's no need to auto scale them. They're just part of your cluster. But if there are 10 machines that are available that could be requested from the provider, then you could create a machine set specifically for those machines. Or if those machines could be included with the other 20, you could have a machine set that manages, the entire set of them. It would really depend on the topology and, what specifically you were trying to do.
Okay, so he's adding a qualification. He's saying, no, it started with a minimum 1 and upscale or downscale from 20 to 30 and 30 down to 20.
So you just want to float between 20 and 30 is basically what you
yeah.
Right. So then, you would just want to make sure that you set, if they're all part of 1, you would just set the minimum to 20 and never let it go below 20. Or if you had some set of 20 that were never going to shrink, then you could create another set of 10 that, as of 4.5 could go from 0 to 10 or something like that. I'd have to know a little bit more about the details, but I think there's a lot of ways you could solve that problem, or probably a couple ways.
I think we got it there in that last one. This is the fun part about restreaming to multiple platforms. You get folks from YouTube, Facebook, and Twitch, as well as Blue Jeans questions. So apologies if we kind of messed up a couple of times. We have one final question, which I think is the philosophical question of the day. It's where would you like to see OKD go next? And maybe Christian and Vadim, you could take that, and then I'll close with a few thoughts.
I would like to see it going at all possible ways at the same time, of course. But there are lots of things how we could extend it. For instance, we're saying OKD4 is based on Fedora CoreOS, but that might not be the case for your setup. We have an example how to build your own CentOS-based CoreOS. You could take Flatcar Linux, which also has Ignition, and hack up your own OKD based on top of that. There are lots of things which we definitely won't accept as a core for the OKD4, but that doesn't mean you're supposed to stop experimenting with that. A bunch of those experiments could lead to interesting solutions. So I would really love to see a lot of experiments and people playing with it, writing guides, and seeing how far could they go with that, changing different parts or even suggesting architectural decisions based on their experiments. But I don't see any definitive, specific place where we want to end up. We would be following OCP as an official part of OpenShift, probably forever. But you still have a lot of ways how to experiment with that. As we said, it's a choose your own adventure type, where you would use trusted things from OpenShift and play with it and extend it in whichever way you like, because all of the source is open and we help with the way how to experiment.
Christian, do you have any other thoughts about where you want to see it go? Everybody has a thought.
Yeah. So for me, the immediate goal, of course, is getting the GA release out. And after that, I would, as Vadim said, I would love to see more external contributions. And really, I want to enable the community to drive their own contributions and drive them into the OpenShift code base. So because OKD will be built off of the exact same code base as OCP, it'll be possible to create PRs against any of the upstream components for community members and have them reviewed by the respective teams and get them in. Also, I'd like to see OKD feature more operators that aren't yet in OCP. For example, there's the OpenShift Acme project, which is a controller that could be operatorized and added to OKD in the future. And yeah, this create your own adventure thing is really what we're aiming for. We want to drive community contributions, facilitate community contributions, and make this a place to test out things while still delivering a stable platform to run your workloads on.
I think you both hit the nail on the head for me. The choose your own adventure, I think that's the t-shirt. That's the thing with the open source distribution is it is the place to experiment. It is the place to do things like try delivering OKD to the edge into IoT devices, the bare metal stuff, all kinds of, things that keep coming up in the working group. So I really hope to have you all who've been listening in to join the Google group. And that's, where I see this going is that we are the place where you can experiment on a stable open source distribution of Kubernetes based on OpenShift and give feedback get some really innovative work. The operators, more operators is always a great thing. And please, as you come up with new ideas and new problems, wherever you are, come back to us and share your feedback. The OpenShift dev channel in Kubernetes Slack is always on, basically. There's always somebody there, whether it's an OpenShifter, an OKDer, or we're all in the same boat, and we're driving it down the river all together. We may be siblings, but we do talk to each other, and we'll keep talking to you guys, and hopefully you all talk back at us. So that's what we had for today. If you guys liked this AMA style session, we'll do it again. On Mondays, we're going to try and host different AMA sessions for different pieces and parts of the open source ecosystem that's around Kubernetes and OpenShift, bringing in different Kubernetes SIGs and working groups and other projects. And so if there's something you want to hear about and talk about, let me know. You can find me on Twitter or on Slack, and I will try and stage these things for you on Mondays. We'll kind of upstream, sibling rivalry, open sourcey projects every Monday at this time slot. So with that, I want to thank Charro, who had to drop off early because he's working in a real enterprise and deploying OpenShift, so he's a cool person to contribute, and Neal and Vadim and Mike and Christian and everybody who asked questions. Really appreciate you coming and spending the time with us today, and I will endeavor to upload this video to YouTube with the slides and all the links that everybody's referred to. So thank you again, everybody, and have a great day and a great week, and stay safe wherever you are.
Thanks, Diane. A lot of fun.